guys, it's Charlotte here from Studentium. So I am here to make your maths revision stress-free and simple. So this video here, we're going to look at differentiation and how it links to working out the gradient of a curve. So if you have any doubts how the two connect, then this is the video for you. You're going to see lots of worked examples so that you know exactly how it's going to come up in your exams and how best to tackle it. So let's get started. Check out the video, make sure you subscribe for lots more videos on how to do A-level maths in a stress-free way. Let's check it out. All right then, let's dive right into this. Okay, so how do we find the gradient of a curve? Basically, the answer is we differentiate it, because don't forget that the gradient is simply a rate of change. And how do we work out what those things are? We differentiate, right? Now, if we go back to basics and we think of if we had a straight line, so how do we find the gradient of a straight line? Remember that we basically do the difference in the y coordinates and then divide that by the difference in the x coordinates, and that's how we always did it for straight lines, and it worked out great. So if we were to imagine though that we had a curve, all right, and we wanted to work out the gradient of a certain point on that curve, the way we would have done that in the past is we would have drawn a line of the tangent and then done exactly what we just said. We would do the difference in the y coordinates and divide that by the difference in the x coordinates. So that is getting the gradient of a very specific point on a curve, okay? But that's not going to help us with the general curve, because on a curve, as you can see on this, the gradient is constantly changing. At some points it's steeper, at some points it's less steep, at some points it's positive, at some points it's negative. So we're not going to get just a numerical value for the gradient of the whole curve. What the gradient of the curve would look like is actually an equation in terms of x, because as every x coordinate changes, you get a different gradient. So how are we going to get that? And this is kind of why we learned this whole new topic, all right? This whole new topic of differentiation, the crux of it is that this is giving us the power now to find the gradient of a curve, all right? That's what differentiation is all about. So just as a little reminder, how we actually differentiate curves. Remember, we times through by the power, we take one away from the power. We times by the power, we take one away from the power. Really is just that simple little pattern that applies to everything that we're learning. Certainly in the first year when we're doing polynomials, when we learn the slightly deeper things in differentiation, we'll learn that different kinds of functions are going to have different rules. But at this stage of polynomials, this is all we need to know. So let's imagine then that we wanted to put this into practice. Let's imagine we're given a curve, say in this case we've got y equals 12x cubed, and we're asked to find the gradient of the curve at x equals 2. So in theory you could draw that curve and do a tangent, but that's going to be hard work, drawing that curve, getting it to scale, getting it all right. So because this is a curve and we want to find its gradient, what we really want to do is to differentiate it using our little rule that we've learned, that we're going to times through by the power and then take one from the power. So if you'd like to try this yourself, by all means pause the video here and then see if you can do this. See if you can find an equation for the gradient of the curve and then find that gradient specifically at the point x equals 2. All right, so let's differentiate. So if we times through by 3 and then take 1 away from that power, we're left with 36x squared. Because 12 times 3 gives us 36, and 3 minus 1 gives us a power of 2. So that thing there, that 36x squared, is an equation that represents the gradient of that curve at any point of x. So when they then say find the gradient at point x equals 2, all we need to do is substitute into that equation x equals 2, because then that will pinpoint the gradient at that point and give you an outcome of that gradient at x equals 2. So in this case we substitute it in and we get 144 as our answer. So let's try another one now. So here we've got a new curve. We're told that y equals 2 root x and we're asked to find its gradient at x equals 1. Okay, so first things first here, again, we're told gradient of a curve. Our brains just need to translate that into, I need to differentiate. So now, if we look at this, we need to remember that's written as root x. It doesn't have a little numerical power. It's not in the form x to the n. So we need to fix that first. So root x is the same as x to the power of a half, okay? So 2 root x is 2x to the power of a half. Now we've rewritten it like that, we can apply our normal rules of differentiation, whereby we multiply through by the power and then subtract 1 from the power. So in this case here, we're going to do just that. So we're going to times through by a half, and then we're going to subtract 1 from the power of a half. So that leaves us with dy dx equals 1/2 times 2, which just cancels out to become 1, and then x to the power of a half minus 1, which gives us x to the power of minus 1/2. So that there is what the gradient is, the equation of the gradient of this curve, which enables us then to work out at any point along the way here what that gradient is. In this question, we're specifically being asked to find the gradient when x equals 1. So we would want to substitute that number into the gradient equation, and we'd end up getting 1 to the power of minus 1/2, which just gives us a value of 1. So there, that is the answer to our question. The gradient of that curve at x equals 1 is simply 1. And you could find the gradient of the curve at any x coordinate now that we have the equation for dy dx. So let's try another question out. Okay, so this one's a little bit different. Here we're asked to find the points at which the gradient of the curve y equals x cubed minus 2x is equal to 0. Okay, so if you'd like to try this one out, you just pause the video here and see if you can get it. All right, but let us explain this now. So find the points at which the gradient of the curve is equal to 0. So here they've given us a numerical value for the gradient. So what we want to do is we still want to differentiate this to get a formula for that gradient, an equation for that gradient. But then once we get that, we're going to put it equal to the 0 that they've said it is. So here, first things first, let us differentiate this thing. Let us differentiate x cubed minus 2x. So by using our rule, we take it 1 by 1. So first let's differentiate x cubed. We times through by that 3, and then we take 1 away from the power of 3, and we get 3x squared. And then we've got minus 2x. Now remember, whenever it's just an x and we differentiate that, we can just drop the x. So minus 2x differentiates to give us minus 2. So we know that. And then we're also told in the question that the gradient is equal to 0. So we can put those two things together now, and we can say that that dy dx, the 3x squared minus 2, is now equal to 0. And now you'll see this has just turned into an algebra question. We need to rearrange this now to solve it to get what x is. So by rearranging that, first things first, you would add 2 to both sides. You'd get 3x squared equals 2. Then you divide through by the 3, and then you would square root it. Now don't forget that at A level, when we square root things, more often than not, we're going to put a plus or minus on it because there's 2 values for it that would work. So here, for the x coordinates, we get x is equal to plus or minus root 2. And because in this question they didn't just say find the x coordinates, they said find the points, I would go the extra mile there and also work out the y coordinates as well. And we do that just by substituting those x coordinates that we just found individually back into the original equation. So then that leaves us, when x is equal to root 2 over 3, if we just put that back into that original equation, that y equals x cubed minus 2x. So it looks a bit crazy, but if we put that into a calculator, you will get an outcome of minus 4 root 6 over 9. And likewise, if you do the same thing there with x equals minus root 2 over 3, substitute it in, again, let your calculator do the heavy lifting here, we get 4 root 6 over 9. And then that would be our 2 points at which the gradient on that curve is equal to 0. So that has covered some of the main highlights of this topic. Main thing is, just know that dy dx means gradient, okay? So whenever you're asked to find the gradient of a curve, they're actually just asking you to differentiate. So what can you do next? I would say practice some more questions on this topic, and just don't forget that when we differentiate a curve, it gives us an equation for the gradient of its tangent. Perfect. Well, great speaking with you, and good luck. See you in the next video. Bye. So now you've finished that, I really hope you are clear now on how differentiation enables us to have the gradient of a curve. That's all it is, really. That's why we're differentiating it. And I really hope that that's now absolutely clear as to why to do it. Make sure you subscribe so you see lots more videos, lots more worked examples, and lots more exciting things that I've got to come on this channel. Leave a comment below if there's anything in particular that you want me to cover and to explain to you. I'll see you soon. Bye.